Hey everyone, today's video I just want to make something real quick to show you how I set up my condensate drain line assemblies on air conditioning systems when they're located in the attic. The picture you're looking at right now is a full cut we're working on. I had just finished up the drain line assembly and I'm just going to run you through it real quick, what I do, why I do it. So what we're looking at here is our primary drain line and our overflow. For those of you just learning this kind of thing, the primary and the overflow are going to be slightly offset. The overflow is going to be just a little bit higher than the main drain line. If you look inside the overflow, it'll actually be halfway blocked off with a piece of plastic, and that's just to ensure the main drain line is actually plugged up before the water actually starts overflowing. But as you can see here, I have a float switch right off that overflow. Sometimes I'll actually put it on the primary side right at the trap itself or before the trap. Whenever you put a overflow switch in the main drain line, you always want to do it before the trap because the plug itself usually occurs somewhere around the P-trap. So having the flow switch before that trap ensures that the flow switch will actually be activated. You can also see I have a union cut right into the line off of that main drain line. The reason why I do that is because sometimes you might actually have a clog right off the main fitting there, and having that union there makes it a lot easier to kind of access that. Otherwise you have to cut the tubing, eventually come back with a coupling, glue, primer, and all that. This way it's just real quick, disassemble, clean it up, reassemble it again. Now a lot of times I'll just use a regular PVC P-trap fitting. I do like using these easy traps, and one of the reasons why I like these is because it already has a T worked in there. I just have to pop that little cap off and I can go ahead and clean out that trap. The other reason is because on the other side I already have a fitting to be able to put in a vent pipe. Now a vent comes in very handy when you're running drain line across the attic and you're going all the way down to the side of the house to ground level. What can happen sometimes, you end up with this water stuck in a straw effect. Now, if you ever put a straw in a cup of water, put your thumb over it and then release your thumb, all the water will fall out of the straw. The same thing can basically happen with your drain line. With this vent, it's like taking your thumb off the straw. It always allows air to get behind the water so that gravity can do its thing. Now you can also see in this video, I put blocks underneath the drain line and I clamp them down. I screw the blocks down to the plywood and then I clamp the PVC onto the blocks, and this ensures that I have a pitch all the way down. The line will not sag or move. You're always going to have people over the years coming in and out, and I just want to make sure that drain line is always going to be properly pitched and there's not going to be any issues that lead to ceiling damage. Now on the drain pan, it's a little bit of a different setup. I don't see a lot of people doing this at all, but this is actually a process that a very tough inspector forced me to do once, and I kind of hated him for it. I'm a little bit of an old guy, cranky and set in my ways, but once I realized the benefits of this, I actually prefer to do it this way now. So what you're looking at, obviously you have the float switch on the drain pan, and you'll notice I have a PVC ball valve there. Now this ball valve stays in the closed position. Downstream of this ball valve, you have a Y that goes back into the main drain line. Now, I've never been a fan of doing that. I've never done it. I've never liked seeing it, but with this particular setup, I'm okay with it. Now, to code in most places that I know of, if you have a float switch in the drain pan, you don't really have to run a secondary line from the pan to outside. If you don't have a flow switch there, you do have to run a drain to outside, and it has to be terminated in a visual spot that the customer can see, so if water is ever coming out of it, they know a problem. With this tactic, there's two things I like about this. One, it does not allow the system to continue running in an overflow state, because sometimes it might take a while for a customer to really notice something's wrong with their system. They might not see that pipe overflowing. That closed valve stops that from happening. The second reason I like it is because when I come on a service call and the system shuts down on that float switch, I don't have to drag a shop vac up into the attic to suck out all the water in that drain pan and make like 2 or 3 trips back and forth. All I got to do is open that PVC drain valve and it just drains right into the Y and right out the main drain line. Another reason why I like this tactic is because I'm a big fan of minimizing the number of penetrations from the inside of the house to the outside. So if I only have to run 1 drain line instead of 2, that works for me. So this tactic, basically what it does is it saves a little time on the install, since you don't have to really run a full drain line all the way out. It saves time on a service call. If you ever, you don't have to lug your shop vac up and down. It's a little better for the homeowner because they have fewer penetrations, fewer entry points for bugs and rodents and that sort of thing. And it's literally one of the toughest inspectors I ever worked with wanted it done this way. So it's definitely up to code as far as I know. So I think it's a win for everybody. So let me know what you guys think. Do you like it? Do you hate it? What do you do? This is not the only way to do it. There's a lot of different ways, but let me know what you think. Thanks for watching.